Alrighty, test 1 2, test 1 2. Is it working? Is it working? I just set up. This whole stream is scuffed. That's the moral of today's stream. I spent, I think, the better part of an hour and a half trying to get alerts to work on OBS Studio, and they didn't ever. So then I set up the entire stream extremely quickly on Streamlabs and was able to get it working, maybe? Do the alerts work? So it says someone subscribed a minute ago. Thank you for the subscription. Did it pop up as an alert? Or did I fail in my only mission? I can't tell. I don't know. I wasn't looking, so I might have missed it. Someone tell me it worked. Please. Someone tell me the funny dinosaur popped up and it said so-and-so is subscribed. There's not many of you to verify. I just need to know. Anyways, today's problems are not too bad, and I started this stream extremely later than I wanted to, so we might be going through them pretty fast today. Generally, I like to take time for questions and stuff. No, it's supposed to be notifying on screen when someone subscribes. That's the dream. I'm trying to be able to thank people individually. Right now I don't even have a background, it's the default, so it's going to be hard to see on this like black paper. I mean on this white paper, wow, because it's white text, but I'm just hoping that it appears. So the notification would have been about 2 minutes ago. But anyway, yeah, hopefully that works for this stream. I'm trying to get alerts open so when people, if we ever get a super chat, I can thank people. But I can see when people subscribe now, which means I can verbally shout them out, which is better than we had before. Very small incremental improvements. The goal for being a good streamer is 50% more effort, 5% return. I think we're there. I can read names now. It only took me like 2 hours. But anyway, we'll be starting here in just a second. Welcome to the stream, everyone. For those of you who aren't here, we're going to be following a University of Chicago Math GRE Prep. We're studying for the subject test at the moment. I'm going to be kind of like flying through these problems really quickly because I got places to be, man. It's my fault, but I wanted to at least get the stream up with the possibility for alerts. I think my bar might have been too high. I could have just gone with what we had going, but you gotta shoot for the stars. Anyway, I will start doing math here in a moment. I think I'll wait a couple minutes for maybe some people to trickle in here. It looked like we had like 10 people earlier. That's not too bad. I wanted to start around 4 at the latest, just so you know how far we are off time frame right now. But when I streamed last Saturday, it seemed like we peaked towards the end, which was around 4 o'clock, so I'm just going to try and start there. But generally speaking, the goal for the schedule is going to be streams Monday and Friday. It's just I've been off kilter since I had one late stream, and since then it's been like Tuesday, Wednesday, Saturday, man. Just not been on time. So yeah, hopefully the alerts work. If they don't work, I will still verbally shout out when someone subscribes, which is awesome. It's still improvement. So yeah, like I said, we'll be getting started here in a minute. How's everyone's day been? It's Saturday here. I had a good Saturday, actually. I went up to the lake with my family and ate lunch there, and then I came back to do this stream, and yeah. So, all in all, pretty good day. It's been pretty nice. It's nice to go out to the lake while the weather's still nice, because summer is ending rapidly, and once fall kicks in, it's going to be really cold. I wonder if this view count is accurate. See, it says 4 here, 4 here. Okay, it is accurate. Thanks for coming, the 4 of you here. Thanks for coming. Alrighty, I guess I should get into the math since my timer's up for the amount of time. Okay, so let me flash up the first problem for you guys. There we go. So the first problem, problem number 12, is how many similarity classes of 2x2 complex matrices are there such that a to the n is equal to the identity matrix? Okay. There we go. I got to get used to it because I just changed software briefly, so if I'm slow in transitioning, you have my apologies. So let's see here. Okay. So, can you guys see my iPad screen, all right? So let's go ahead and write our definition for similarity first so you guys know what we're talking about. So we have that A and B are similar if there exists P such that B equals P inverse A P. Yeah, I like good notes. Okay, so for this problem we have two cases. So we have case one, which is we're going to dive right into, and that is diagonalizable matrices. With an equal to I. A to the n equal to I, sorry. So what does that mean? Well, right away we can see that a to the n minus I is going to equal 0. And so that means that p of x is equal to x sub n minus 1, and p of a is equal to 0. Whew, sorry about the yawn. It also says that m sub a of x divides p of x. And here, this is the, here, I'll put it on top actually. This is the minimum. So we have this result that says the roots of m sub a of x are the eigenvalues of a. So applying that to our current problem, we have that the eigenvalues of a are the roots of our equation, which was, oops, x to the n minus 1 equals 0. Which is, of course, x sub n equal x to the n, sorry, is equal to 1. So then we have that, oops, a is of the form, we have in, oops, here, let me just do this bigger. Can you guys see the bottom of the screen here? I don't want to, like, cut it off. Okay. Yeah, I have a habit of like writing where you guys can't see, so I have to be careful about not doing that. But it looks like I nearly avoided my camera. So yeah, okay. So a is of the form where we have the first entry is an nth root of 1. Then we have 0, 0, and then we have another nth root of 1. So how many possibilities do we have here? Well, when we are taking all the possibilities of this and this, we have n choose 2 possibilities. But then we also have to add on n more possibilities for when these are the same. So that's going to be n choose 2 plus n. Let me make sure I'm not too small. Okay, I can write under this. Good. I think on the old setup there was a little room cut off the bottom, but it looks like not here, which is great. So the definition of n choose 2 is n times n minus 1 over 2. and we're going to add n to that, and that's going to be equal to n times n plus 1 over 2. So that's all of the possibilities for the first case where we have, or those are all the similarity classes for the first case. So let's go to the next page. The second case is pretty quick. Not diagonalizable. Well, that means that we have A has to be in this form because it's a 2 by 2 matrix. It can only have like one form if it's not diagonalizable. And so we have A has the following form. So we have lambda 1, 0, lambda. And that means that A sub n is not equal to the identity. And if we take powers of n, we can see that a squared is going to equal lambda squared, lambda 0, lambda squared. And then for the nth power, just like generally, we'll have this. So because we have no solutions for this, it will contribute no additional similarity classes. Okay, so our final answer is the number we had for our first case, which was this right here. And that is, which answer? E. That's our total. Okay, cool. So let's bring up the next problem. Alrighty, so we want to know what the set of solutions to this equation below are for x and y in R. So we are taking the determinant of this matrix here, and it's equal to 0. So we want to find these solutions here. Yeah, let me open up a new page here. So we can see by cofactor expansion, our determinant is going to be this. We'll have x minus y times the determinant of cosine of x, sine y, sine of x, cos y, and that's going to be equal to 0. And that will give us x minus y times cosine of x, cosine of y, minus sine of x, sine y. And this is actually an identity, a trigonometric identity. And this is equal to cosine of x plus y. So we'll have that times x minus y. And that is also equal to 0. So for our solutions, we have x is equal to y. And then this will give us that x plus y is equal to pi over 2 plus n times pi. So those are our solutions, and that means we need to pick one of these like union ones for the answer choices. Yeah, it's a relatively easy question. So that will be, let's see, x equals y, and which one is that? Pi over 2 mod pi. Yeah, so that'll be C. So that is answer choice C. Alrighty, let's move on to 14. Oops. Oh, no, it's not cut off. It looks like it's cut off, but it's actually not. So we have suppose f is continuously differentiable with f of 1 equal to 1 and f prime of 1 equal to 2. And we want to find the value of the derivative of f of e to the 2x minus 2 over x times f of x at x equals 1. So we have, let's write down what we have. We have f of 1 is equal to 1. F prime of 1 is equal to 2. We want to find d over dx of, oops, that's too big, we're doing a fraction here, f of e to the 2x minus 2 over x times f of x. Okay. So we need to figure out a way to like write these equations down to solve for f of x. So if f of 1 equals 1, so we have f of 1 equals 1, then we could have f of x equals any power of x. So like x to the n or something like that. And then for f prime of 1 equal to 2, when we plug in 1 for x, we get 2. So that means that x, this is x squared. So f of 1 will equal 1, and f prime of 1 will equal 2, right? Everybody agree with that? So then we will want to take, plug in e to the 2x minus 2. Yeah, so we're just going to take the derivative after that, yeah. So let's like evaluate these so we can just write our derivative real quick. And we'll have, it'll be e to the 2x minus 2 squared over x cubed. We're taking the derivative of that. I guess we should probably do that on the next page. So let's actually like just copy this real quick, and we can go from here. Copy. Paste. There we go. Oh, I got like a line up there. I must have gotten that from the other page. Okay. So we're going to want to use quotient rule first, and then we can do chain rule as needed. And quotient rule is, I believe it's like, if we have, so if we're doing, let me just look up the definition so I write it exactly right. Just for posterity. Yeah, here we go. This is what I was looking for. So dy over dx equals v du dx minus u dv dx over v squared, where like u is on top, v is on the bottom. Okay, so let's set it up with that. So we'll have x cubed times the derivative with respect to the top of e to the 2x minus 2 squared minus e to the 2x minus 2 squared times the, I'm just going to write 3x, I'm not going to bother writing the derivative there, 3x squared all over v squared, which will be x to the 6th. So really the only term we need to worry about here is this one right here, and then we might have to do some simplification. So we can use chain rule here on, so yeah, actually let me just like denote that we're doing this here. Like take this term, and that's what we're working on right here. So we'll have 2 times e to the 2x minus 2 times the derivative with respect to x of the inside, which is e to the 2x minus 2. And then you got to use the chain rule on e, so that'll give us 2e to the 2x minus 2 times the derivative of the power of e, so times d over dx of 2x minus 2 times e to the 2x minus 2, right? So far, so good. Oh, I think I might have cut myself off. Did I cut you guys off? I did cut you guys off. Let me just rewrite. It's not much here. I just need to get rid of this part. Times e to the 2x minus 2. All right, so this is obviously going to be equal to 2. This is 2. Did I make a mistake? I have a no in the chat. I'd rather make a mistake on chain rule than on harder math, but maybe it's more embarrassing to make a mistake on chain rule. Someone want to correct me if I'm wrong? Perhaps. Maybe. I'll wait. Actually, what I'm going to do, I'll be right back. I'm going to go get some water because my water just ran out. I'll be right back. I'll give you time to think about it. Alrighty. I see no further dissenting opinions. Okay, so this will be, let's see, I think I'm running out of room here. This is already kind of like sketchy. We'll have 2e to the 2x minus 2 times 2, oh, so it's that whole thing squared. Because it's just this again, right? Yeah. So this squared. So let's like finish this off on the next page. So we'll have, see, what was it, x cubed times 2e to the 2x minus 2 squared minus e to the 2x minus 2 squared times x cubed, right? No, 3x squared, my bad. That's all over x to the 6th. So we can factor out our x squareds here, and that'll give us x times 2 e to the 2x. Actually, hold on, I feel like we can do more with this. So we could factor out like a 4 here and get that this is equal to 4x cubed times this term. And then we could have x times e to the 2x minus 2 squared be 4x. No. Hold on, I'm combining steps here. The x would be on the inside. I have this times x, 4x, minus 1, all over x to the 4th, because we canceled that squared there. And I don't see how we would simplify that anymore. And then we want to evaluate it at x equals 1. Well, if we do that, this is going to be e to the 0 power, so this whole thing is going to go to 1. And then we'll have, let's see, this will be 4 minus 1 over 1, which is 3, which is not an answer choice. Fantastic. What did we do wrong? Was it when I did the sketchy substitution? 4x, is this supposed to be 4x minus 3? Did I just like lose a 3? Oh, yeah. You're right. Yep. Thank you. Thank you. Yeah, the 3 from this 3 here. 3, and then this will give us, that'll go to 1. This will be 4 minus 1, so it'll be 1 over 1, so the answer is 1, which is D. Wow, the 1 circled looks surprisingly like a D. Let me just make sure that is correct. Yes. Okay, cool. So let's go on to the next problem. The next one I'm not going to even need the iPad for, so I'll just bring up the window capture. Nothing like Calculus 1 to make you feel dumb. I don't know. I took Calc 1 like 6-7 years ago, so I don't know. Like on the stuff that's like easy, it's just like when you're working for something, even if it is easy, you feel like you're going to make a mistake if you're that rusty at it. Anyway, let's bring up the problem. There we go. Okay, so we want to know how many injections there are from... It's 1 to 4, but they put in ellipses, like that's really hard to count to. But yeah, from 1 to 4, or from the set 1 to 4 to the set 1 to 10. So this is extremely easy. As you know, with an injection, you can't have any like repeat mapping, so you can't map 4 to the same number you map 3 to. So we'll have 10 times 9 times 8 times 7, right? 10, 9, 8, 7, yeah. Which is what? What's 10 times 9 times 8 times 7? Does anyone have a calculator handy? I don't know that off the top of my head. 10 times 9 is 90. You want to just like do it try to do it in my head? 10 times 9 is 90. 90 times 8. Yeah, I'm just doing a calculator. Too much effort. I copped out immediately. You don't get to see my cool mental math skills. We got 10. Oops, that's 11. 10 times 9 times 8 times 7. That's D, 50, 40. If someone in chat was doing it, I did it faster. I know there's a stream delay, so I have an advantage, but you know. Okay, so on to 16. So we have, suppose that A and B are 2 square matrices, and that B squared A minus A is invertible, and we want to verify like which of the following is true. Okay, so let me get out the iPad here. Oh, I'm yawning a lot. You have my apologies for that one. Apologies for the big yawn. Okay. So, let's get this window capture. Here we go. All right. Hold on, I gotta close out this window here. Oh no, it's scuffed. Okay, so we have that B squared A minus A is invertible. That means we can write B squared A minus A times C is equal to I, where C is the inverse of this. So we can factor out an A from this and get that, let's see, we'll have B squared minus I times AC is equal to I. And then we can split this B squared up into B minus I, B plus I, times AC is equal to I. Now from here we can see that B minus I, A is invertible. Wait, am I missing something? Yes. Invertible. And if we just multiply our A back into that, we'll have that AB minus A is invertible. And that is answer choice C. So just from like the way we split this up and how we can see that this piece is invertible, we can see that if we multiply the A back through that piece, we'll have that that's invertible. Okay. So let's go on to 17. Let's go onward. I'll just go to the next page too while we're at it. Alrighty. Did it work? No, I clicked it. It just didn't want to do it. Okay. So for here we have compute the following integral. Now, when I looked at this integral initially, I was like, yeah, that looks easy, but I didn't realize there was like an x in front of the sine x here, which makes it more difficult. But Michael showed me a trick that to me felt like cheating. So I'm going to show you how he showed me to do it because it's crazy. I don't know. It still feels like cheating. I told him I'm going to lose sleep over the solution. So let me get that because it's really cool. Got to show you the awesome thing, right? Here we go. So let me get back the iPad for you. Okay. So we have the integral from 0 to pi of x sine x over 1 plus cosine squared x dx. So we're going to do a change of variables. We're going to let t equal, pi minus x, which means that x equals pi minus t. Then we'll have that dt is equal to negative dx. We'll have that sine of pi minus t equals... Hold on, am I jumping? I'm jumping the ship. Hold on. I think I jumped the gun. So let's just call this integral I. So doing this change of variables, we'll have that this is it'll be negative. It'll be negative 0 to pi, but we're going to just flip those to, not 0 to pi. It'll be negative pi to 0 when we plug in, but we'll just flip those back so it'll be positive 0 to pi of pi minus t times sine of t. And that's because we have that sine of pi minus t is equal to sine of t. And then when we plug in the bottom, we'll see that we have cosine squared of pi minus t equals cosine squared of t. So we'll have this is over 1 plus cosine squared of t, and then this is dt. And then we have that this is also equal to changing our variables back to 0 to pi pi minus x sine x over 1 plus cosine squared x dx. And these are both I. So as long as we multiply by a half, we can add these two together. And when we add these two integrals together, we can see that they're going to cancel. So we'll have, let me write that. So we'll have 2 pi equals I plus I. So our new integral will be, I'll write it down here, pi times the integral from 0 to pi of sine x wait, no. We'll have the 1/2. We'll have, just summarizing what we're doing here, we'll have 0 to pi of x sine x 1 plus cosine squared x dx is equal to 1/2. Oh, am I going to cut it off? That's so cool. I think I'm good. 1/2 the integral from 0 to pi of x sine x of 1 plus cosine squared x plus, am I going to cut it off? No. Maybe not. Maybe not. See how small I can write. The integral from 0 to pi of pi minus x sine x over 1 plus cosine squared x dx. Is that cut off in any way that matters? Close enough. You can see it well enough. Anyway, so yeah, so that's going to give us 2I, which is equal to the sum of these integrals. I already wrote that up here. So by this, we'll have that our integral is equal to pi times 0 to pi of sine x over 1 plus cosine squared x dx. So that's cheating. that's my official stance on it. That's cheating. Okay, so let's do that integral really quickly on the next page. We can see that it's going to be pretty easy. So we'll have pi, I guess it's pi over 2, because that's what I just wrote is equal to 2 pi. What I just wrote is equal to 2I. So we need to divide it by 2. 0 to pi, and sine x over 1 plus cosine squared x dx, and then we'll let u equal, see, it'd be cos x, and that'll mean that du is equal to negative sine x, and we'll go ahead and factor dx. We'll go ahead and factor that negative out, so we'll have negative pi over 2. The integral, I'll leave the bounds open, which is bad, but I always do it because it's faster than thinking about the change of variables. This will be 1 over 1 plus u squared dx, and I believe that's a trig function. What's the 1 over 1 plus u squared function? Is that tangent? Is it arctangent? I think it's arctangent, but I'm going to look it up. 1 over 1 plus what does it be? It's arctan. Yeah. It's arctan. I should have stuck to my guns on that one. So that's equal to negative pi over 2 times the arctan of u, and that's equal to negative pi over 2 times the arctan of cosine x from 0 to pi. And if we plug in 0 for cosine, we'll get 1, and if we plug in pi, we'll get negative 1, so that's going to be negative pi over 2 times the arctan of, let's see, pi first, negative 1 minus, or I guess plus, because the pi over 2 will distribute, plus the arctan of 1. And that will give us, what? What do these go to? What's the arctan of negative 1 and 1? Somebody know those off the top of their head? Arctan 1. It's pi over 4. Oh yeah, duh. Yeah, pi over 4 is arctan 1, and then it would be, what, like, what's negative 1? Du not dx, where did I make? Oh, thank you. Yeah, I'll fix that. This goes to pi over 4. And yeah, but it's a multiple choice, so I'm supposed to leave it out. This goes to pi over 4, and then this one goes to, it's like It can be negative. Oh, it's 0 to pi. So it'll be, what, 3 pi over 4? Yeah, that's what I thought, yeah. So that'll give us negative 3 pi squared over 4 plus pi squared over 4, which is equal to negative 2 pi squared over 4. Is that an answer choice? Oh, the 2, duh. That's equal to pi squared over 2, or negative pi squared over 2. Pi squared over 2 is an answer, but negative isn't. Did I mess up a negative? Oh, because this is negative. Is that what you're saying? The negatives cancel? That would make sense. But then it's not the same answer. Then it's just pi squared. What am I missing? It's got to be very simple arithmetic. Let me check what the answer is, make sure we're on the right track. It says the answer is pi squared over 4. What did I mess up? What did I do wrong? Somebody want to correct me? I feel like it's with our negatives and positives here. Arctan negative 1 is negative pi over 4. Gotcha. Negative pi over 4, so that will make this a positive pi squared. Thank you for the correction. And then that'll be pi squared over 2. But that's not the right answer. It says the right answer is pi squared over 4. So we're still missing something. Wrong branch of inverse. Yeah, I'm making some weird trig mistake. It's from 0 to pi. So where it's negative would be, it would be 3. It would be regular 3 pi over 4, right? 3 pi over 4, and then that would make this. That was our original answer, though, wasn't it? Negative 3 pi over 4 plus, but then we still get a negative. Denominator is 8, not 4. Oh, yeah, that's the problem, I think. Yes, thank you. So this will be, let's just rewrite this. So this will be negative 3 pi squared over 8 plus pi squared over 8. It's okay. We have to fumble at the end. This is my entire lifetime experience doing integrals, is do the calculus right and screw up the simple stuff you've known since what, like high school? In order for this to be, oh yeah, this is the correct answer. I don't know. So that'll be negative 2 pi squared over 8, which is pi squared over 4. That's the answer, but we're supposed to lose the negative. Is this negative? I'm calling it negative. I'm calling it negative so we get the right answer. Somebody want to, like, verify that? Negative. Just so that it works. I can't be wrong. It's the question that's wrong. Come on, guys. I can't be wrong. It has to be the question. I think we're just going to move on. I'm not that worried about it. Okay, cool. All right. We have confirmation from the chat. I now have confidence. Cool. Oh, yeah. You're right. Yeah, see, I should have changed my variables. Anyway, we're just moving on. I'm not worried about how minor that is. All right, so let's go to the next one. And that is, we're going to compute this limit. So let me flash that up on the screen for you. So we have the limit as h goes to 0 of f of x plus 4h minus 2f of x plus f of x minus 4h over h squared. So let's go ahead and do that. I'm just laughing at chat roasting me for simple mistakes. So we've got the limit as h goes to 0 of f of x plus 4h minus 2f of x. Hey, this is why it's a study stream, guys. Come on. Come on. We are studying. If it wasn't, plus this whole day's been scuffed. If the problems weren't scuffed too, it just wouldn't feel right. So we're gonna let delta x equal 4h, and we can see that as h goes to 0, delta x goes to 0. So we'll have a new limit as delta x goes to 0 of f of x plus delta x minus 2f of x plus f of x minus delta x over, what would that be? Delta x over 4 squared, something like that. I think that's right. Let me check my notes to make sure I'm on the right track. I think that's the substitution I made. Yes, yes. Perhaps. Wait. Why do I have this as delta x squared? I have this as delta x squared. I don't think that's right, though, in my notes. It just can't be right. That's just not how that works. That's just not how that works. Right? Okay, well, we're going to use a Taylor expansion for our terms here, namely this one and this one. So we have that f of x plus delta x. I didn't mean to start a war in the comments. Is equal to f of x plus f prime of x delta x plus 1/2 f double prime of x delta x squared plus delta x cubed times some stuff. And for the other one, we'll have f of x minus delta x is equal to f of x plus f prime of x times negative delta x plus 1/2 f double prime of x times negative delta x squared plus negative delta x, you can't see this, cubed. I think you can understand where it goes, and then all that's minus 2 f of x. So I think this limit is related to Newton's method. What problem are we on? We are on problem 18. So we can see that a bunch of this stuff is going to cancel, and we'll get, I'll just do it on the next page, we'll get that we have f double prime of x times delta x to the n plus delta x cubed times some stuff over delta x over 4 squared, right? And what's that? Oh, let's not even write it like this, because this, yeah, so this will flip up as 16. So this equals 16 times that stuff. F double prime of x. Is that it? Oh, yeah, because this stuff doesn't matter, because this is not an n either. This is 2. So as delta x goes to 0, this goes to 0, and this cancels, and then we get this. It's not. It's just wrong. I read my notes like a dummy instead of, excuse me, thinking with my brain. Yeah, it's a squared. So those cancel, and this goes to 0 when you take your limit. So we just get f double prime of x, and the 16 comes up from this denominator. Yeah. This is simple. I just read my notes instead of using my brain. Yeah, so that's just 16 f double prime of x. To like skip over the cancellation here, but you can't see all the terms, but it's pretty easy to see because of the negative. Alrighty, so let's move on to 19, because I don't want to dwell on each of these problems too long. I've started stream 2 hours late as it is. Okay. So this is just like an integration by parts problem. We have, please work, thank you. The integral from 0 to 2 of the log of 1 plus x squared dx. Alrighty. So let me just like kind of sketch out why it's an integration by parts problem, because I feel like people didn't like tell me this until I got, well, ever really. So let's write out our integral first. 0 to 2 of the, what is it, log 1 plus x squared dx. So this is of the form, it's like of the form, we have an inverse function times other dx. So you want to use integration by parts for that. When it's transcendental times transcendental, I'm just going to say that instead of writing it because I'm going to need the space. And then transcendental times like a polynomial. So we're going to, so it's like integration by parts. We'll have that u is equal to the natural log of 1 plus x squared. And then dv is equal to dx. So that means that du is equal to 2x over 1 plus x squared, and v is equal to x. So that means we can write, just write this. This is our I for integral. I is equal to x times the natural log of 1 plus x squared. It's just integration by parts. From 0 to 2 minus the integral from 0 to 2 of, what would that be? 2x over 1 plus x squared dx. And we can write, we're gonna here, let's just do like a box. Plus 2 and minus 2. So that lets us write this as negative the integral from 0 to 2 of 2 dx plus the integral from 0 to 2 of 1 over 1 plus x squared. And this piece will give us 2 times the natural log of 5 minus 4. Well, this piece gives us minus 4, and then plus the arctan of 2, as the 0 does not contribute. Okay, I kind of did that really fast. There's your comedy there's your comedy for the day. The coaster came with the glass, and then it went all over the floor, and so did the water. Not all of it, though, just some of it. Does that make sense? I think that's a pretty simple integral, so I went over it really fast, but integrals are fun. Okay, cool. Cool. All right, so let me bring up the next problem. That is actually cut off. Well, that sucks. Hold on. Can I like zoom this out really quickly? Just like, it doesn't want to work. Can you zoom out, please? Por favor. Initial boundary. Yeah, that's also an IBP. Let me see if I can't fix this real quick, because this is going to be a problem later anyway, so we might as well fix it now. There we go. Centered. Yeah, so we have a topology problem. We have the set of integers z. We're going to let fancy u be the set of all subsets of z that are arithmetic progressions with, well, that's just the definition of arithmetic progression, which is basically just like add multiples of natural numbers to some integer. And we're going to let x be the integers with u as a base. We want to know which of the following is true. So I'm going to go ahead and tell you all three of these are true. Oh. Initial boundary value problem. I gotcha. See? And the more you know. Maybe it's not a... Oh, the iPad went black. Hopefully that doesn't ruin Streamlabs. I hit the lock button, force of habit, and sometimes when you like... Excuse me. When you like lock the iPad, or when I would like transition between scenes, the camera would go out for no reason. So, you know, just nothing is allowed to go right in stream. So I'll go ahead and tell you that all of these are true. The sequence one's actually pretty interesting, so I'll sketch that out for you, and I might do some on number 3, but I think it being metrizable is not crazy. So let me show you the sequence one. Here we go. It worked. We're not sunk. Okay, so let's go ahead and define like what it means to converge to 0 in this topology. So I'll just write you down like a result, or like a definition. We have a sequence. This is like straight out of the textbook, by the way. A sub n for n in natural numbers in Z converges to 0 in top in the topology, if and only if for all k in n, there exists big N in n such that n bigger than or equal to big N implies k divides a sub n. So basically a sequence converges to 0 if and only if any positive k is a divisor of all members whose index is sufficiently large. It's like a... So here we go. And like it's like a classic example for this n factorial. But I think from this definition it's pretty clear why that's the case. So this is like... I feel like I should have denoted this as a definition. So this is what you use for 2. For 3, we have so you can see that if we have I guess I should probably see who that is. I'll be right back. Let me mute Sorry about that. Okay. So for 3, so let's like kind of like quickly investigate. I'm gonna have to go here in a second. So if we have some s from the integers to the integers, and s of m is equal to m plus n. This is for addition being continuous. Then we have that s is a minus b, a plus b, a plus 2b. What am I talking about? Dude, I might just skip this problem altogether. I don't feel like I can fairly explain this. There's an A in here, by the way. Yeah, I think I'm just going to skip this problem. I'm going to skedaddle here in a second. Okay, so let's flash up problem 21. So we have suppose that G is a finite group and that all of its conjugacy classes are the same cardinality. Moreover, suppose that P is prime and to be or not to be, yes. P is prime and P to the n divides G, but P to the n plus 1 does not divide G, and we want to know which of the following is true. First of all, it's worth noting that 2 implies 3. So all we need to do is like prove or disprove 2 and 1. So let's do that. So let's go ahead and write the following fact. It's not letting me write anything. There we go. I don't know what was going on. Fact. We have if the order of h equals p to the n, then h has a subgroup order p to the m for all m between 0 and n. Next, it's worth noting that the order of G is equal to 1 plus the size of non-identity conjugacy class times the number of conjugacy classes. But we have from our statement that all the conjugacy classes are of the same cardinality, which means that they are all the identity. And this means that we can't say that one is true, because say we have H is equal to G. Oh, you just see the question? Thank you for pointing that out. I forgot to get rid of this. Let me get back to where I was. Hold on. But anyway, what was I saying? I was saying, yeah, so they all have the same cardinality, so they're all the identity. So if we were to write our definition for that, for like conjugacy class for X, we'll have that it's just X in G. So that means that like our definition for the conjugacy class just writes that it's abelian. So if it's abelian, this kind of like statement of the conjugacy classes being the same cardinality implies abelian, which implies group automorphism 3. And because we have this abelian, we can, if we were to write for 1, the subgroups of order p to the n minus 1, we could have different values. So if we have like h equals g h prime, not the inverse, g inverse, this is equal to h. And we could have different values for these two. So that means one is wrong. And just abelian, this part proves 2 and 3. Just to like go through it really quickly. And 22 I can actually do correctly in like 5 seconds. So I want you guys to, this was supposed to be my funny joke for the stream. So let's see. So we have the following multiplication tables. We want to know which represent a group. Okay, so like this should be like a speed question, right? So for the first one, we have C is repeated in this row, so that doesn't work. This one doesn't have an identity. You can see that very quickly. And we don't talk about the third one. That's just not a group. That's just not a group. We're not going to talk about the third one. This is the joke. This is the, we're going to make fun of this third table. Everybody has to point and laugh at the third multiplication table. Point and laugh, point and laugh, point and laugh. I have to end stream. I want someone to write an argument that is wrong in the comments as to why 3 is a group. See who comes up with the best one. I think it's just because all A is a pretty cool group. Anyway, today was not easy peasy. Yeah. So that's the last one in this set of problems for week 3. I'll be starting week 4 hopefully on Monday at maybe 11 o'clock. Sorry for stream today being so scuffed, but I got started late and I'm like running on different software and it's just been kind of like really hectic. But next stream should be much better, so definitely keep an eye out for that. Hopefully I can verify that the alerts and all that work, but I think next stream is going to be really good, so I definitely keep an eye out for it if you're free on Monday at 11. If not, the stream will go live after the fact on the channel. I think it just takes a few hours. YouTube has to process it or whatever. But yeah, definitely keep an eye out for it. If you want to go back through these and take some time for yourself, you can always go back and